Hydrogen combustion engines have bridged to sustainable mobility in 2025. Hello, everyone. Today we will explore a topic that gaining great attention in the transition toward clean transportation. Hydrogen combustion engines offers the potential to power vehicles with zero carbon emissions. And unlike batteries, it can be used in internal combustion systems that already exist today. Hydrogen combustion engines are designed to operate much like conventional gasoline or diesel engines, but instead of burning fossil fuels, they burn hydrogen gas. This approach allows the reuse of existing engine design and manufacturing processes, meaning that industries can adapt more quickly without needing to fully replace current technologies. When hydrogen reacts with oxygen inside the cylinder, the main product is water vapor, not carbon dioxide. This simply chemical change makes hydrogen combustion an appealing way to drastically reduce greenhouse gas emissions while maintaining familiar performance characteristics.
Recent study published by the Royal Society of Chemistry in 2025 provide viable data on how hydrogen combustion engines actually performs. The research compared several engines configurations for standard hydrogen spark in-situ advanced turbocharged system and found efficiency level of around 40 to 45%, which are comparable or even slightly higher than those of diesel engines. But the key concern identified in the study is NOx emission. Although hydrogen itself contains no carbon, high temperature combustion can cause nitrogen in the air to react with oxygen, uh, forming a small quantity of NOx. The RSC study measured this emission under different conditions. Some optimized configuration, such as those using selective catalytic reduction filters, achieve as little as 1.9 milligrams per kilowatt hours of NOx, while convection diesel engines emit over 3,000 milligrams per kilowatt hours.
While research advances rapidly, several companies are already bringing hydrogen combustion into practice. As reported by the Sustainability Times, Toyota has taken a leading role, modifying while research advances rapidly. Several companies are already bringing hydrogen combustion into practice. As reported by the Sustainability Times, Toyota has taken a leading role, modifying traditional internal combustion models such as the Corolla has vans to run on pure hydrogen. Similarly, the work of Bosch, Cummins, and Alpine, which are developing hydrogen engines for heavy-duty trucks, bus, and motorsport applications. These projects show that are particularly variability in sectors where electrification remains difficult, such as long distance or industrial transport.
However, this technology still faces key challenges. These include storing hydrogen safely, ensuring efficient fuel transports, and preventing the formation of nitrogen oxides, which can appear during high temperature combustions. Despite this challenge, hydrogen engines represents a powerful option for reducing emissions now, without waiting for full electrification. In addition, hydrogen combustion depends on the development of clean hydrogen productions, known as green hydrogen, generated using renewable energy sources such as wind or solar power. Expanding this production capacity is essential to make the technology both sustainable.
To achieve ultra-low emission, engineers apply several innovative strategies. Among them are land burn operation, which use a high R-to-4 ratio, advanced as exhaust aftermath system, such as CRC and catalytic reduction and precise control over combustion time and temperature. This solution allows hydrogen engines to drastically reduce NOx level while maintaining high efficiency and performance. As the RCRC study concludes continue research into the methods in the essential to make hydrogen combustion five both environmentally compliant and economically practical for mass production. By integrating in the system hydrogen combustion technology raises the possibility of combined zero carbon operation with the robustness and familiarity of traditional engines.
Looking ahead, the large-scale adoption of hydrogen engines will depend on two main factors. First, the ability of the green hydrogen, and second, the development of refueling infrastructure to support commercial and public transport systems. Although these challenges are significant, they also drive investment in hydrogen technologies. Experts see hydrogen combustion as traditional break, rate, and final solution, a technology that helps reduce emission now while fuel cell and battery system continue to evolve, while only policy support industrial innovation and advance in hydrogen production. HUIs could play a crucial role in achieving carbon neutral mobility over the coming decades.
In conclusion, hydrogen combustion engines demonstrate how existing automotive technology can adapt to support a clean future. They combine family engineering with innovate for use, drastically cutting CO2 emission and paving the way toward full decarbonization as research industry and renewable hydrogen production continue to advance. H2Is stand as the key bridge between today's transportation and the truly sustainability mobility of tomorrow.